And we're live. Awesome. Okay, well, welcome everyone to this week's Python Thursday, and I'm really excited tonight because we have a special demonstration from Craig. He's going to show us an Arduino board, and hopefully we'll get a chance to see all the wonderful things that it can do. Um, so yeah, if without any further ado, I'll go ahead and hand it over to you. I'm excited to see this.
Cool. Sounds great. Thanks. So, this is an Arduino board, and it is a microcontroller. And if you can see the item that sort of looks diamond shaped, but really is just a square down there. I guess you could say like almost bottom center or so. And that is the microcontroller that is on the Arduino board. And in a few moments, after I point out a couple of other things on there, I'll show you what the microcontroller is and point to a data sheet for anybody who wants to get extra geeky and dig down into the data sheet for that thing. But you can see that there's several rows of pins. You can see there's 3 red wires coming out of one set of the pins of the header, and then 3 more red wires coming out of the one to the left, and then a yellow wire. And then towards the bottom of the screen, you should be able to see a green wire coming out of a set of pins down there, or a set of pins down there. And so what I actually have configured with the red and the green wires, and then there's a black wire that you probably can't see that's kind of tucked under the board there. I basically have set up 5 volts and ground that come from the Arduino board and connect over to the breadboard. And we'll take a look at the breadboard in a few minutes. But my default wiring setup is to connect, the 5 volts from the pins all the way over to the circuit board with the green and the black wires under there. So that's basically the power that powers everything on the breadboard itself. So the Arduino board is powering the circuitry on the breadboard.
Mm-hmm.
Now you'll see sticking out of the left-hand side of the Arduino board a USB connector, and this acts as the data interface and also power. So right now the Arduino is being powered off of my laptop, but if you look down towards the bottom of the screen from that, so the bottom left-hand corner, you'll see what looks like a little turret, a little terminal there. That is the power jack that you can hook up a wall adapter to. So you can get a wall adapter that feeds it. I forget what the voltage is on this, but and the current, but you could feed it right from any type of, go to Radio Shack or even anywhere where you might be able to get some of those general purpose wall plugs that convert AC to DC, and you can plug it in there. You can also power Arduinos with batteries. Not quite sure, what type of life you'd get out of them with batteries. At least an Arduino of this size. The smaller versions of Arduinos, maybe you would be able to get, better battery life out of. If there's fewer components on there and such. But this can be driven by battery. Right now, I just have it hooked up to the laptop for the power.
How would you hook up a battery?
You could there. So in this case here, you've got that turret down there that has that. It has basically a jack on it that I think this one. So I think this turret looks like it's got a prong in the center. So it's probably a male connector, and you would plug in one of the female connector types. And so on that mating jack, you would probably find ways that I've seen them sold. They actually have devices that will plug into that jack and then connect to a small battery pack or something like that that you could connect onto the back of the Arduino if you wanted.
Okay.
So there's when you do go out and you search Arduino, there's so many things that people are coming up with these days for these things to power them. It's unbelievable. Now an Arduino of this size, it's going to take a fairly decent amount of current, to run the microcontroller that's on there, and to supply current for the output pins and all that stuff. So you definitely want to make sure that you have a power supply that can handle the current it's going to need to deliver. But when we talk about smaller Arduinos, they probably won't draw as much current, so you could probably run those off of batteries with no problems.
Awesome.
You can see on the board, you can see there's an LED lit up. That's kind of that big green blob off to the right-hand side next to the word Uno. And that corresponds to a pin, and that's basically saying that the Arduino has power and that this is all powered up. Now, when you unplug the data cable to the Arduino, as long as the Arduino has power in any way, whether it be just a plain USB cord that just has power but no data, or whether it be a battery pack or a wall outlet or a wall plug, either way, once you disconnect that data cable, that Arduino will continue to run that program over and over and over again until it loses power. And that's one of the kind of the cool things is that once you program this to do what you want it to do, you can be detached from a computer completely, and it can completely run on battery power after that. So that's a really nice feature of this type of thing. Okay, and of course I'm sorry.
I said that sounds really cool.
Yeah, that's what's really nice about it, and we'll talk a little bit about some of the portable ways people are using these things. Some really, really ingenious kind of things that people are using Arduinos for. And there's other versions of microcontroller boards as well. Instead of just Arduino, there's other ones as well. Okay. So if you'll take a look at those connectors, if you see I have 3 red wires coming out of one of the connectors and then 3 red wires coming out of the other connector. And that basically is those are the output pins. And we'll talk about those in when we go look at the code. And then you'll see the one yellow wire that is coming out of that connector as well. It looks like that's, I think, on pin. So I think pins 10, 11, and 12 have the red wires. Pin 13 has a yellow wire. And then I think I put those in 3, 4, and 5 on the other side. So those wires are going off to the breadboard. We'll take a look at where they're going. So basically, we have these wires coming out of the Arduino board going to a breadboard. And let's see here. So I think what I'll do is I will share out my screen and then switch.
Do you need a grounding wire?
For the circuitry, yes. So there is a ground wire that I have pre-wired up. So the black and green wire, I don't know if you can see those easily or not, but they're sort of towards the top left of that image. You'll see that the black and green wire go into the breadboard, and it's kind of hard to tell, but you might be able to see a plus and a minus sign.
Yeah.
On the breadboard underneath those. So I actually have the Arduino board itself powering the positive and negative on the breadboard. And so anywhere in my circuitry where I need plus or where I need ground, I'll take it off of that whole terminal that is marked ground, and then if I need 5 volts, I'll take it off of the plus terminal or anywhere off of that. And we'll talk about this little kit that I got here as well, and it's kind of a nice, neat little thing that you can, it has the Arduino built into it, and then it has breadboard. And this Arduino is only really snapped into this plastic, I guess you could call it a kit. So once I'm done with this, I could take that Arduino off of there and put another one on, or take this Arduino and make it dedicated for something else. So that's kind of a cool thing there. So I think what I'm going to do now is I'm going to switch to, make sure I have the right file open first. Okay, before I go and do that. So I'm going to do screen share. And then okay, now you might be able to, do you see a web page with a schematic on it?
Yes, we do.
Okay, cool.
Yeah.
Great. Okay, so this is a pictorial diagram of what we're looking at there. And so let me zoom in a little bit there. All right, so that's what we're looking at there. You can see the 5 volts coming off with the red wire on the left-hand side of the Arduino, and then that goes over to the positive terminal on the breadboard. Now, everything, how many of you folks have actually used a breadboard before?
I have.
I know Tiff. Yeah, I know you have, Tiff.
I have not.
Okay.
I have.
Okay, so the concept for the breadboard is, if you were to just kind of look at this breadboard, and if you take a peek at those pins, those holes that are inside the breadboard. So inside those holes, at the bottom of the hole, and then I think around the diameter of the hole, there's metal inside there, and it all connects. Now the way these connect is if you go in the middle, say where the top red light is, and you'll see that one blue wire is coming out of there and going down to pin 12. That wire and everything that sort of has like a green tint to it, that is all connected together underneath the breadboard. So any pin that's put in that row will connect to any other pin that's in that row. Now you'll see in the middle, between the LEDs those lights seem to jump over something, and that's what we call the gutter. In that gutter, there's no connection between the 5 pins on one side of the gutter connecting to the 5 pins on the other side of the gutter. So basically, that's how you can create circuits using a breadboard. Is you just push the wires down inside that little hole, and as long as the diameter isn't too big, to poke the hole out or to cause any problems, it just goes down inside the hole and it makes a connection to any other pin that's in that row on that side of the gutter. Now, on the outsides of the board, you'll see there's blue and red lines that go vertically up and down that breadboard. So the red line that goes down shows that, or is giving me an indication that everything in that whole column is connected together. So the top red wire all the way down to the bottom red wire, all of those are connected together. So any pin that I would stick in one of those holes is connected to the plus 5 volts. And similarly, the ground, or the black wire, comes in from the ground of the Arduino, and then it is connected into the terminal that's nearest to this blue strip. And if you follow the blue strip all the way down, everything that would be connected there is all connected together. And so you kind of see that I have actually the black and red wires jumpered across to bring power and ground to both sides. So this breadboard works in a way where the central portion is where you can build your circuits and you can have connectivity between parts. And then those 2 vertical lines on both sides allow you to run power and ground all the way up and down the sides of the breadboard there. So it's kind of a neat way to hook up a circuit without having to do any soldering, without having to do any wire wrap. If any of you have ever done wire wrap, Tiffany, have you done wire wrap before?
I've seen it done, but I've never done it myself.
It's kind of crazy at times because you may think that the wire is wrapped tight enough, but it can just pop off, that kind of a thing. So wire wrap, is one of the older ways to do this type of stuff. Of course, there's soldering, but once you solder something in, you have to unsolder it, or it's basically there for good, unless you unsolder it. So this is a nice way to build circuits without having to really, mess up any parts or, get dirty or get your hands dirty and that kind of stuff. So it's kind of a neat way to build a circuit. So right now I just basically have it prototyped on this breadboard here. So on the breadboard you see there's power and ground. And if you look down the right-hand side of the diagram, you'll see what we have here, 6 resistors. And these resistors, I won't go through all the details, but each of these resistors has a value of resistance, and that's going to impede the current a little bit. I shouldn't use the word impede, but what it will do is it will lessen the current flow that is going to flow through these LEDs. And so what we actually have, and I'll scroll down to the schematic where it'll actually make a bit more sense. So this is the schematic view. So we have ground, and that's this symbol down here that kind of looks like 3 lines that diminish in size. The current, if it were, you would follow the current flow through the resistor, the 100 ohm resistor, then through the LED, through this, and then up to this pin here, D3 or pin 3. Pin 4, same thing, has an LED that goes down through a 100 ohm resistor and then to ground. So this is a more, this is a schematic diagram that technicians, electronics engineers actually use to lay out or to show you what the circuit is doing. So basically we have our 3 LEDs, a red, yellow, and a green on this side, and then 3 LEDs on this side here. So the resistors are there basically to limit current through the LED so that you just don't burn the LED out and such. LEDs, you could probably run them without current limiting resistors, but you do want to have a little bit of something to draw the current down a little bit so you don't burn out the LEDs.
If you use the higher resistor, would that would sort of make the lights a little bit dimmer? Or
that's correct. Exactly. So yes, less current, less brightness. I think if you go and poke around in some data sheets for some LEDs, they will probably specify a minimum amount of current before they even turn on.
Okay.
So that would probably be where you'd want to specify, okay, I probably don't want to go above this value, and I probably don't want to go below this value. So you can kind of get an idea from like an LED data sheet as to what size you might need if you want to be, in the middle of an operating range, or how bright you want it to be. But I mean, that is one thing I could do here, a little bit later on, is I could pull one of those resistors out and put a higher, value in there, and you would see the LED would dim.
All right. Cool.
Yeah. Cool. Yeah. So we can even do that, when we get a little further, and if we feel adventurous enough and want to do that, yeah, that's cool. So so we're looking at the schematic and the breadboard, the pictorial diagram. And so these LEDs, that stands for light emitting diode. And basically it's a semiconductor that when you pass current through it in a particular direction, it lights up. And so that direction, it has to be current passing in a particular particular direction. Current flowing in the opposite direction would not turn the LED on. So LEDs are polarized and do have to go into the circuit a specific way. Resistors are not polarized. They can go into the circuit either way. It doesn't really matter. But you'll see that on my board and on the demo board, I like to keep my resistors kind of in the same orientation so that you can read the values off of them. Now these resistors, they each have their values coded on there. And if you want to, there's a way to figure out what those values are, and that's all over the internet. You can find a resource for that, what these color codes mean and such. So that's the simple circuit of the LEDs, of lighting up the LEDs. And so of course you can see that we've got the green LED, the yellow, and the red LEDs. So there's 2 sets, and these LEDs are going to, let me see if I have the other image open yet. There it is here. Okay. So, it's probably a little too big. Okay. So what I'm simulating with this is I'm simulating a main street and a side street. And so there's a light for the side streets, and then there's a light for the main streets. Now, ideally, you would have, you would have double the amount of lights that you have here, one for each direction. But in this case here, I just basically have the 2 sets of lights to simulate, one of them, the main street, and then the side street. And so you'll see that the main street and the side street each have their red, yellow, and green. And you'll also see something interesting on the side street. How many of you have ever pulled up to a traffic light that is sitting there and it's been green for a while, and you're sitting there at that traffic light, and all of a sudden, after a certain period of time, you get the green light, and then you can go? Well, how many of you have ever noticed that there's a certain period of time, and if you weren't sitting there with your vehicle at that intersection, more than likely that main street probably wouldn't have changed to give you a green light? In most cases, there is either a sensor cut into the pavement. I've seen those. There's been it's sort of like a metal tape that's kind of pulled, that's kind of laid down into the grooves that they cut into the street. Or they can actually have optical sensors that sit up on top of the light poles that kind of point downwards. They might even have motion detector type things to see if there's a mass of a certain size inside that view. So whatever that sensor might be, indicates that there's somebody on that side street that wants to, get a green light. So in this case, what I was doing for my model is that I was modeling that the main street always had green unless somebody pulled up and hit the sensor on the side streets. And then I would set, once the sensor was tripped on the side streets, I would wait for a minimum amount of time and then give the main street a yellow, wait a little bit more time, give the main street a red, wait a few more seconds, and then give the side street a green. And then the side street would have a certain amount of green time, and then the side street would go back to yellow, and then go to red, and then after a certain delay, the main street would go back to green. So that was just the pattern I set up for this. It was kind of I kind of got this idea because I had actually done this as a project back in college, and I didn't do it with software. I didn't have the Arduino back then. I basically did this with integrated circuits and wire wrap and wrote my own code for an 8186 processor way back when. So I wrote assembly code for this and burnt it into a PROM, and then the processor executed this program and such. So
how did that experience compare to doing it with the Arduino?
Oh, that was definitely a lot more complicated because, of course, the 8186 is a full processor, so you kind of have to bootstrap it and dedicate it to running a particular type of running code right off of the EEPROM and that kind of a thing. So there were some tricks that we had to play there to get that to run that dedicated code. It was actually, the wire wrapping was a lot messier. With the Arduino, you can kind of plug some things in, and you can find ways to, get around that kind of thing. And the code, if anybody who's online has ever programmed an assembly code,
I have done a very little bit.
Okay. If you've even done just a little bit, you know what painfulness it is. I've even heard people who have complained about C++, and I kind of look at them and say, well, yeah, C++ might be painful, but assembly is a lot more painful because that's what's underneath C++. Underneath everything is assembly, basically. So, that's kind of the nice thing, about, say, the Arduino is that the language is abstracted up a bit, so that you don't have to worry about, writing to the machine code. So that's kind of nice. Okay. So does anybody have any questions on the what the real world simulation is I'm trying to do here?
No, I think we're good.
I think we're good.
All right. So we'll sneak back for a moment and take a look at the schematic. Now on the schematic, there's one thing I did not put on this schematic, and we'll talk about that in a second. But I did want to say that there's these cool programs that go along with. There's a program called Fritzing, and here's how it's spelled down here is Fritzing. And this program has the template for the Arduino in it, and it has templates, blocks, if you would want to call them, for the resistors and the LEDs. And basically, in this program called Fritzing, you just drag and drop parts out of a library that you want to place. And this breadboard was a block in that library as well. So Fritzing, I used Fritzing, rather quickly to kind of sketch up the circuit and draw the wires in there. Once I told Fritzing where the wires were and what things were connected together, once I had those connected, then I switched in Fritzing to something called the schematic view, and now I was able to see the connections between all the parts. And so you could make the connections in the schematic and then look back to the breadboard view, or you can make the connections in the breadboard view and then look back to the schematic, and they would be connected up. So that's kind of a neat thing there. Is this Fritzing is really cool. There are people that make libraries full of parts for you, those kinds of things. Manufacturers even make libraries for their parts and everything. And as long as I was having some problems with it at one point in time, but let me see. As long as it doesn't crash the system here, let's cross our fingers. Okay, so Fritzing is loading up. And And so this is the the interface for fritzing, and I'm going to go and open up my traffic light demo. And you can see on the right-hand side, here are the parts in my library that I can pull out. You can see there's basic parts for the core, my parts if I define my own parts, Arduino parts, and you can see all the Arduino boards that are there. Here's the Arduino Nano, Arduino Ethernet board, shields for the Arduino, and we'll talk about what shields are in a little bit. You can see there's actually companies that will supply you kits. There's one called SparkFun. I think this one here, Seed Studio, is another one that supplies kits as well. Intel parts, if they have breakout boards and such, analog devices, all different kinds of manufacturers with all of their parts in terms of a library. So basically, all you would want to do is, if you want this part on the schematic, I could just basically pick up one of these parts and drag it and drop it right in the schematic. And then if I wanted, say this wire to connect to this wire, basically just hook them up, and there's the connection there. So that's kind of cool. Yeah, it's kind of cool. It's pretty ingenious. I think this kind of stuff is pretty cool. And
that is really nice.
Yeah, and if you really wanted it to, you could go to check out what I've done here is the printed circuit board. So if I wanted to, what I could do, and I actually am going to do this, because I'm going to make kits out of this for like use in libraries and things like that, is that you can turn this into a printed circuit board. So basically, you'll see all the LEDs are on in here, and I actually routed the connections, the copper connections, by hand myself. But you can use what's called an auto router, and if you press this button here for auto route, it'll go and try the best case guess at how to connect up the pins and everything. And what's really cool about this, and you're gonna probably freak out about this one, is that from within fritzing, you can actually go and right here. Do you see what that says? Might be a little difficult, but
is that to order the printed circuit board?
Yes, you could actually just click that button, and with a couple more clicks and some information and that kind of thing, it will send off all of the artwork files it needs to create this board off to a vendor, and basically you'd be then sitting at a website page where you can enter your information and credit card and all that kind of stuff, and they'll ship you these boards once they make them.
Whoa.
Yeah. So you can see what I'll be doing here in the next couple of weeks is ordering a couple of these boards. And actually, you can see there's the part here that I haven't placed yet is kind of sitting there, and so now it's asking me, okay, do you want to place this part? So I would place the part. Once I place the part, I could go and say, okay, auto route that, and you can see that it's already figured out that my connections are already done, but now it's actually saying, oh, you do need to reconnect this back up. So it made this connection here for me. So if you noticed, it did a nice, neat little, jaunt there and came down here. Now, me being an electrical engineer, I wouldn't be happy with this connection between this pin and this wire, just because it's too close in that particular case. But for a free auto router, it's a pretty good product. So
that's really cool.
Yeah, it is. It's definitely something that if you really wanted to tinker around, you could really spend some time doing this kind of stuff, and you can actually rotate the parts. If I wanted to make this board smaller, make it cheaper, I could move these parts, make them more compact, and then reroute everything. You can see that it actually has the pins exactly as it is on the Arduino. And what would really be kind of cool about this is that if I take these pins here, and when I mount these pins, or when I build this board, I could put pins on this board from the other side and then lay it right on top of the Arduino, and those pins would drop right into the connectors of the other pins. And that's where they get the term shield for Arduino shields. They're basically boards that you can plug in on top of the Arduino board to make it do other things. So this is kind of cool. And you could actually, in Fritzing, you can actually even store your code right inside the project as well. And I don't know, does Fritzing have any way to... It looks like it does. This is really cool. I haven't played with this yet, but it looks like Fritzing will actually say, oh, I see you're designing to an Arduino, so I can even help you upload your code right to the Arduino. So you could probably design everything right here in Fritzing. I just think that's really slick.
It is. It's like a one-stop shop for playing with electronic hardware.
Exactly. It's that kind of cool. So I'm gonna not save that. And like I said, you can see there's lots of other parts libraries here. You can actually go get other parts libraries off of, people make. I've seen a lot of people out there make parts libraries for things. And when you're clicking around on parts, when you click on a part, it'll tell you about that part. There's a photo cell, a proximity sensor, all different types of parts. Give you some details about it. Who makes it, what the pictures look like, and such. So that's Fritzing, and that's kind of a cool thing there. Fritzing, I have had some problems with installing Fritzing at times on Windows. Fritzing is one of those applications that doesn't have a lot of overhead in terms of installing itself. So sometimes it just kind of drops files in places and drops a shortcut along with those same files, but it doesn't set itself up in the start menu as an application in the start menu and that kind of stuff. And I don't actually think they even enter anything into the Windows registry and that kind of thing. That's kind of a cool thing, but there might be a few steps you might have to take if you're running on Windows. I think Fritzing might also work on Linux as well, or maybe even Mac, but I've been using it. So that would be what my circuit.
Yeah, it works. It works on Linux and Mac. I just checked. I just downloaded it.
Oh, cool, awesome. Yeah, that'd be great to know. It's probably going to be a little bit easier to use on Linux or Mac. I mean, to get set up with, at least at first. And I also think that I understand that installing other libraries, add-on libraries, might be easier in a Linux than a Mac, because I think in Windows you can't install them from a program. I think you have to unzip them to a specific folder and that type of thing. So you just kind of have to pay attention to where you're unzipping things and that such. Okay, so that's kind of the hardware of this. And so before we go over and take a peek at the code, let me flip back to the well, actually, we can come back to the lights in a couple seconds. Does anybody have any questions on the hardware so far? No? Okay, cool. All right, so we'll go on to the listing. And this is probably what a lot of us, we're kind of itching to see is the code. All right, so here's the code. And I won't walk through every line, but basically this is a variant of C, and I do understand that the Arduino will pretty much run any C code that you dump into it. It will run pretty much any C++ code as long as it has the libraries in its in its compilation areas. So you probably couldn't do crazy things, I would think, from C++. You might be able to do standard template stuff like vectors and maps and those types of things if the library is there. I just kind of have a feeling that I doubt the library is there, because one of the things that most Arduino projects kind of thrive on is the fact that you don't have a whole lot of memory on the board that you're putting this onto. You don't have massive amounts of RAM like you do in a computer, or a laptop. So basically, you're trying to kind of get as much done with less code. So I don't think they would have all the advanced features of, a full C++ compiler type thing. So, but I do believe that you can create classes in here or structs as well. And so you can kind of see this has a C look to it. Has anybody online so far not programmed in C+ or C or C++ yet?
I haven't done any C.
Okay.
I haven't done C either, but it kind of reminds me of Java in a sense.
Yes, Java and C are they're kind of very close. In fact, Java and C++ are, I've heard people actually call them, parallel languages. They're very parallel to each other. A lot of what you would see, a lot of the syntax is similar. A lot of the structures are the same, the concepts are the same. They're definitely like languages for sure.
Yeah, there's a lot that looks familiar. I haven't used it before.
Right. And so if we take a quick peek at this, so we see we have a bool, and I set up a variable called test mode that I'm setting to false. So this is whenever I compile the program. So if I want to run this in test mode, I would change this value to true, and then that way it would be running in test mode. So you can see here that I'm doing one of the things that people say is an absolute no-no, is creating global variables. And in the world of Arduino programming, you don't really have the niceties of structure of like full C or C++, where you want to program defensively, I guess you could call it. A lot of people say, "Oh, globals are bad. Globals are bad." But when you're dealing with something that's 40, 50 lines of code, and you've got really, really tight functions, and everything's pretty much procedural, you don't really have to worry a whole lot about global variables. In fact, global variables will save you some trouble or save you some time having to, type a lot of things over and over again, and actually, memory as well. So in this case here, I set up, this is all I'm doing here, setting up integer values so that I can define a variable called first light green and setting it equal to 3. And you'll see that comes into play a little further down. If we follow down here in this function called setup, we do something here called pin mode. And I'll just give a quick on that for a second. Pin mode, the first argument to pin mode is the number of a pin that you want to configure. And so in this case here, this first light green represents 3, so it would substitute the number 3 in there. So this here says use pin 3 as an output pin. And this is where the Arduino language comes in a little bit here, is that the Arduino API is in this library. So you will have things that are not full, I guess you could say, C. They're not like absolute C, because if you look in my code, you would look anywhere through here, you would not be able to find where this output is declared. And in this case here, the Arduino library itself sees this as a declared, I guess you could call it like a pound define, if you're familiar with C or C++. Basically, this would convert that output to whatever that means. So in this case here, you're basically just kind of saying, okay, pin mode, the number of the pin, and set it as an output. Same for all of the other pins as well, all of the ones that we're going to show as a display. And now you're going to look at, I'm setting up a pin, in this case here, input secondary road, which is pin 13. I'm setting that up as an input. So now, if we go off to Arduino's website, I don't want to lose any of those links I have up there, so I'll create another tab. So we go off to Arduino's website, and if we go to their reference manual, so they have their whole API listed out online on their website for free. You can get to this as much as you want. The only thing you really have to buy in this case is the Arduino board itself. You don't have to buy any, ability to see the code reference or anything like that. That's all for free. And if I go to where's the pin modes here? Conversion, variables, utilities, that's a byte, interrupt. Oh, there we go. Okay, digital I/O, pin mode. So if I look at the reference sheet for that, basically says that it's going to configure a pin to behave as either an input or an output. You can see the description for more details if you want to see the functionality of this. So if you really want to get down to the the electrical engineering level of what those pins are doing when they're in input mode versus output mode, you can go to their reference manual and dig a little further deep to find out what's going on. This kind of gives me a hint here that they're actually using pull-up resistors to limit the current. So if you specify a pin as an input mode, they do have something internal to kind of protect that circuitry with a pull-up resistor there. So, and here's the syntax for that. Parameters kind of looks like a regular data sheet that you would find on, say like the Python website or MSDN or anything like that. So neat little data sheet. They even provide examples as well. And there's the pin mode, and there's the setup of it, and there's some more code there, and we'll talk about those in a little bit. So and then the analog inputs pins can be used as digital pins as well. So one of the things that this version of Arduino I have does is provide me with so many input pins or output pins. The smaller versions of the Arduino don't have as many pins on them, so you kind of have to. You're kind of limited in the amount of pins you have. Of course, it's more portable, but you're limited in the amount of pins you have. So if you want more pins, you kind of have to get a bigger circuit board. So those are kind of some of the trade-offs that you kind of see that you might face when dealing with Arduinos. If you want something ultra portable or ultra small, you're going to run the risk of having fewer pins. So you may have to think your controls a little bit differently. So programming and design kind of gets a little interesting when you're dealing with Arduino and embeddable code and that type of thing. Okay, so there's that. So now that I've done a whole bunch of talking, there's actually a data sheet. You can find off of the Arduino website a data sheet on the microcontroller that's inside there as well. So you can kind of go through and kind of geek out completely on all the specs and everything in the data sheet. There's 660 pages to this data sheet right here. So have fun with that one. All right, so let's go to something where, okay, so I think what I want to do at this point is I want to go to the circuit, and so let's stop sharing. If I stop sharing. Okay, so you probably see the circuitry now, right? The Arduino board is up?
Yep.
Okay, great. All right, so I'm going to get my big old clunky hands in here for a second. Move that down just a little bit, and then pan with the control here. All right, okay. So you see the LEDs in there now, right? Okay, you can see the circuit. So the LED, and I want to make sure I word this properly so I can see what you folks are seeing. There should be a green LED on the far right that is lit up, and then a red LED on the far left that is lit up.
It's the opposite of that on my screen, but I don't know if that's just me.
Okay. So
No, it's me too.
Okay. So then it's kind of backwards. Let me get that. I wonder if maybe turning the light out here might work a little bit better. Let's see. Is that a little bit better for everybody?
Yeah, that looks good.
Okay, good. All right. Okay, so on your the one that has the green LED, is that on your right or left?
Left.
Okay, it's on your left. Okay. So that is the main road, and the other one is the side road. And so right now they're sitting in that holding pattern where the side road has red, the main road has green, and I have a little push button switch here off to the side that you can't see that I'm going to push to simulate that a car pulls up. And you'll see there's one little LED kind of sitting, kind of bent over there at the bottom. That will flash really, really quickly, and that's just letting me know that that the switch is inputting there. Okay, so that flashed really quick. So we go through 5 seconds of a delay. So then the main road goes to yellow, and then goes to red, and then the side road goes to green,
That
And
was awesome.
so the side road now will have 10 seconds of green, and after the 10 seconds of green, it gets 4 seconds of yellow, and then red, and there is a bit of a delay, for the other one before it goes back to green. And then it'll sit in this pattern here until we press the button again. Say another car pulls up, and there's a small delay there, and then it starts the cycle again.
Cool.
That's so cool. It's just like a real intersection.
Yes. I tried to get the timings fairly close to something realistic, and one of the things that I was looking up specifications, getting all kind of geeky on it, the project and everything, and trying to find like some kind of data sheet for a real intersection somewhere, so I could tell somebody, hey, this is what the lights do at this particular intersection. But when I found some of the timings there, I thought to myself, for a demo, this is going to be, pretty intense, because somebody's not going to want to sit there for the demo and wait 20 seconds for this light to, change. So
Yeah.
I kind of made the timings a little more demo friendly. So
It's cool. The button gives it a little interactivity too.
exactly. And that's kind of what the folks, when I did this, several weeks ago at the Engineers Week. The people were like, "Oh, can I press the button again? Can I press the button again?" I was like, "Sure."
I think if I had that in front of me, I'd just be sitting there like, press the button, press the button.
And what I was going to do, and I just decided against this, at least for the demo, is one of the requirements I had back in the original project back in college was that when the side road went to green and then went back to red, the main road had to have a minimum of a minute of green. So even if somebody pulled up to the side road, they'd still have to wait until the main road had green for at least a minute. So there was an extra condition I had in college that I didn't want to really add into this demo. So. And then, of course, you can think of all of the intersections near you and think of all the complexities that they add in there. Another, complexity that you could add in another switch is, when somebody presses the walk button. Those could be, extra points to the, extra inputs to the project. I even had, I wish I would have thought of this and got the extra credit for it, but when I was in college, one of the other teams, we were in teams when we were doing this just to kind of save on expenses. One of the other teams came up with the idea of having what they called an ambulance switch. That they had an input that simulated somebody driving by in an ambulance, and the ambulance basically, they kind of pressed a button or did something, from within the ambulance that made all of the lights in the intersection go to red, so that the ambulance could go through the intersection much faster and that kind of a thing. So they got some extra points for doing that, and that was kind of cool. Okay.
I'm coming up with all kinds of ideas for projects.
Yeah, I mean, even just lighting LEDs, you can come up with a number of different things. I've actually seen people who have just made LED timing projects and all kinds of things like that. So it's kind of interesting with that kind of stuff. And so you might be wondering, okay, so if we're looking at the code, and I'll flip back to the code here for a second. So we're looking at the Arduino board, and before I go back to the code and everything and show you how it uploads, so this is the project itself right now, and what I'm going to do is I'm actually going to pull in a different project from somebody who is online right now. And he made a different version of this, and let's see if we can get his loaded into the Arduino. Now you'll probably see the lights flicker and such. Let's see if it compiles and uploads. Okay, so the lights went out. All right. So this is a what did you call this, Jamal? your traffic light party?
Traffic party? I don't know. Something like that.
This is Jamal's traffic light party here. So what he does is he flashes all of the lights, I think twice, once, twice, and then green, yellow, and then red. Although,
Uh-oh.
somebody catch the bug?
Yep. That's going green on the right-hand side for me.
Exactly. Yes. And what we'll do is when we go back to look at the code, we'll figure out what that is and we'll change it, and then I'll show everybody how the upload works.
Awesome.
So it's kind of cool. All right, so we'll let that run for a couple seconds here, and I'll share out my screen yet again. And this time, I think I probably want to switch to something in the background so I don't see. Okay. All right, let's go back to the screen sharing. And there we go. All right. So here's Jamal's Party Light demo. And this font's probably kind of small, so let's go and preferences, font size, 20. Is that better, or do you folks need it up a little bit bigger?
A little bigger would be good.
Okay. So let's go to preferences, and let's make that, let's try 24. See what that looks like. Better?
Yeah, that should be good.
Okay, good. All right, so.
And just to be clear, I didn't actually write all this code. I just took your code and played around with it a little bit.
You didn't have to go through that. I was going to give you credit, Jamal. Exactly. So yeah, and so we'll walk through. I actually have this code up on GitHub if anybody wants to, fork it and change it around like Jamal did, and then he did the pull request, and I accepted the pull request, and I pulled the file down and compiled it and everything. And the one thing that Jamal did not have that I had, and I probably should have told him about this ahead of time, and I forgot, was that you can dump it into this Arduino. So here's the tool set for Arduino. It's basically it's an executable that comes up and has its own built-in editor. You can tell it to use your own editor. I haven't tried that yet, just because most of the circuits I've been doing in Arduino have been pretty simple. I haven't really needed my own editor yet. But in Arduino, you can configure several things. I think like where you keep your files. Show verbose output during compilation and upload. If you're really geeky and you want to see what's going on during compile time, you can turn that on and see those. You can have it display line numbers and code folding. So it's a decent editor for this. It's not bad. And then we'll talk just for a few seconds here about like how the Arduino works. So there's a function here that's called setup, and this setup function basically is the thing. This is what the Arduino microcontroller itself and the Bootstrap language that is put inside there that reads your code. It says whatever the person writing the code puts into the setup function, whatever they put in there, I'm going to process that one time when you power up the board. And so basically that's where you put all of the functions where you want to say, okay, this is how I'm going to set things up. Everything in setup only gets run one time. So you probably wouldn't want to have any information in setup that you couldn't get to any other method. If once setup runs, any of the functions or variables that are local to this, they won't be local to any other functions if you're going to start dealing with scope and that type of thing. So that's another one of the reasons why sometimes global variables are good in this thing here, is because once setup runs, it'll never come back to setup again. So setup is a one-time only type thing. For the moment, you can ignore this lights test pattern, and then you can ignore the all lights pattern, ignore each of these for the moment. We'll come back to those. The main function that gets done over and over and over again until the batteries won't wear out or you remove power is the function called loop. So you always have a void function called loop, and everything in loop will get done over and over and over again. Once it's done with loop, it'll come back and start loop all over again. So this is the guts of what you are normally doing. So you can kind of see that your program here, you can consider this, if you're familiar with C++, this would be your main function. This Python has a concept of a main, right? I believe.
Yeah, sort of.
You can set your code up that way.
Okay. Yeah. So you kind of have a concept of a main. So this is what would be running all of the time. So in this case here, I'm testing a variable. If it's test mode, then I run this test lights pattern. And I basically put this in here for myself as kind of like a defensive developer in the sense of I want to make sure that I have this circuitry wired up correctly. I want to make sure that each light lights up when I tell it that it's supposed to light up. So that's why I put this run lights test pattern in there for myself was, okay, if I'm going to wire this, I want to make sure the wiring's correct. If I'm ever going to break down the board and rebuild the board or even test the circuit boards that I have made, running the lights test pattern will walk me through turning on each of the lights and making sure they all light up. So that was just my way of testing this. So the bulk of the code is actually down here where we go into the else statement. So we're not in test mode, we go into the else. And you'll see we call a function that says green lights on pattern. So that must turn the green lights on. Then we call a function in the Arduino API called delay that we pass it a millisecond delay. So in this case here, it's 500 milliseconds or a half a second. You'll see further delays down below is 1 second. These are all 1,000, so that's all 1 second. You can make that delay as big as you want it to be. It'll delay for 15 seconds if you make it, 15,000. It's kind of just that, the one thing that's kind of different for people to kind of get used to who are not familiar with programming. People that come at this from, say, just a hardware background, or even people who don't have any programming or hardware background. One of the things I've heard from some of those folks say, well, why does it say 500 if it's just a half a second? Why not just put 0.5? That was one of the arguments I've kind of heard at times is, if you want this to be in seconds, just make it say seconds. So that's one of the things that's a small hurdle for some folks to get over once they start working with this. This is in milliseconds. So this green lights on pattern, let's go find that function and find out what that does. So the green lights on pattern does what's called a digital write to this pin number, and it specifies that it's going to be a high. That turns the pin on. The next one goes to the first light yellow and says that that's going to be a low, turning the pin off. If you remember when we had the schematic up, and maybe I'll flip to that real quick here. So in the schematic, if the pin is high, that puts 5 volts at the top of the LED and ground at the bottom. So that would turn that LED on. If pin 3 goes low, that puts a low voltage or 0 volts or ground at the top of the LED. So 0 volts here at the top of the LED and then ground at the bottom of the LED. There's not going to be any potential difference, no difference in voltage, so there's not going to be any current flow. So the LED is going to be off. So now you can see how the high and low go into the code to kind of, represent what we're doing in hardware. So let's flip back to that. So basically this is just saying apply a high voltage to this pin, apply a low voltage to that pin. First light red is going to go low, second light green is going to go high, low, and then high there. So that would turn on just the green lights. Okay, now you see we have the yellow lights pattern. Of course, the ones that are yellow get the high voltage. And right here is where we have, our bug. So we'll go in here and we'll say, okay, let's make that. Second light green is supposed to be low, and that's supposed to be high if all the red lights are on. Okay, so then the neat thing about this, and maybe I'll kind of, now I've tried to find a way to take this code. You can kind of see some orange code or orange text at the bottom. I've tried to find a way to make that bigger. I could not. So, we won't worry about the details of it. But if you watch when we're uploading, it does its compile phase. Now it's actually trying to upload to the controller, and it has succeeded, and it's done. Okay.
It's so polite. It thanks you.
Exactly. Isn't that really cool?
Yeah.
Yeah. I mean, I think they did, basically put some kind of cool stuff in there. If I can see back, I think they did something else here too. They actually go into geeky stuff there. You can get to see all the details of it. Most of the compiler output, is kind of strange. If you did something where, let's say, you forget semicolon, which is bad in C or C++, and if I try and upload that now, you're going to see I have a compile error, and then it tells me what the compile error is, and it kind of tells me what line that's on, so I can go to that line. And it's actually, in this case here, it's kind of highlighting that line for me. So it's a smart little editor as well. And then I can put that, semicolon back, and it should recompile. And there it is. So if we flip back to the Google, turn off the screen share, and go back to the controller, now you'll see that Jamal's party lights work as he intended them to.
Woo!
And of course, as everybody is used to seeing, now I can actually go and, let's take this code, copy that file, go into here, paste it, and all right, let me go back and get the screen share back on so people can see what I'm going to do next.
It's interesting that you obviously wouldn't be able to have a traffic light demo with just software, but at the same time, a lot of the logic is still in the software. So like, you're just swapping out different software into the same hardware, and it's doing something that's completely different.
Exactly. You've hit that right there on the head. And actually, I was going to bring this point up later, but now is as good a time as any. One of the things that this really, really obviously bright young lady had said to me at the Engineers Week, she said, so if you're going to, I'm trying to remember some of the words, she said, if you're going to write this software and then you upload it into that device, I said yes. And she looked at me and she said, well, you could do that over the internet and not even have to go to the light to reprogram it. And
True.
at that point, I was like, do you need a job? That's a programmer I want. That's somebody I want, on my team programming right there.
Yeah.
Until the chip has to be reset.
Exactly. Yes. That's when you deal with something like that, then you have to go out there. You have to send somebody out there to go do it. But if you just wanted to change the timings on the lights, and that's why sometimes I wonder, why, Department of Transportation has some things so screwed up is, it just seems like it could be easier.
So you could run a program maybe that, like, at certain times of day it changes the timings on the lights, and I mean potentially.
Exactly.
I have seen lights like that.
Huh.
Yes. In fact, I mean, the industrial park where my company's office is, from during rush hour, from like 7:15 in the morning until I think 8:30 or almost 9 o'clock, the lights have a certain sequence. But if you go at lunchtime to this intersection, there's a completely different sequence. It's that interesting, it's odd.
Interesting.
Yeah. So so what I was going to do with this real quick is let's see. So we've got here. So everybody can see my screen, right? I think, did I share my screen? Okay, good. All right. So what I'm going to do anybody who's online that has not dealt with source control yet. I think everybody who's online pretty much has, but anybody not deal with source control? Okay. Well, if anybody who's viewing hasn't, you're going to get a little bit of a bonus here. You're going to actually watch me check in this file. Okay, so I'm using Git, and we can see that we've modified Jamal Party Light Demo, and then the INO file. And I'm basically going to go and say that I want to add and do my Git commit. There's my Git commit, and then I'll do my Git push, and it'll go up to the server. And let me just do that real quick.
And this is the part where I'm glad that I wasn't in charge of the traffic light update.
Always have a problem with my GitHub password because it's than my other passwords. Okay, there we go. All right, so the next thing I kind of wanted to kind of walk us through or kind of look at was everybody here has done this before. Everybody who's online has done this. Of course, the code is up in a repo, up on GitHub. So if you want to modify this, go ahead and feel free to modify. You can download the compiler from Arduino, and you can actually compile. It might be hard to see because it's kind of small on my screen, but there are two buttons up here. There's verify, one that looks like a check mark, and the other one that looks like an arrow is upload. Upload will run verify and upload, which is basically a compile and an upload. Whereas if you just click verify, that will just run the compile step. So even if you don't have Arduino hardware, you can at least compile and do a verification, to make sure that it compiles correctly for your circuit, until you can get it into your circuit. And so, here's the stuff up on Traffic Light Demo. Oops, I'm sorry, that was the wrong link. And so we can see that if I go to my graphs, that's not the one I was looking for. Okay, we can see there's two forks of this so far, and I hope to see others. If anybody else wants to play around with it, feel free to play around with this. And if you're doing something and you say, oh, I just really want to see if this works, feel free to fork it and do a pull request to me, and I'll download it to the Arduino and even record a little video for you and post it somewhere if you want, just so you can see your changes in action before you go and get yourselves an Arduino. If you feel itchy enough that you want to do that while your Arduino is being shipped to you, because I know everybody's going to go get one now, right?
Yep, I'm going to get one. I got to play with this.
And so this is the really cool stuff about all of this is, okay, so now the other thing that I thought of talking about, unless anybody has any questions at the moment. Nope, not yet? Okay, cool. So one of the things that I thought, okay, this is Python Thursday, right? We can't have an Arduino demo without trying to do something with Python and an Arduino. Well, guess what? Well, guess what? It's out there. People are doing it, and it's possible. Let's see if I still have this. Okay, so Arduino and Python, even from the Arduino website itself, one of the things that people have identified as being clunky with an Arduino is talking to the Arduino itself. Like, once you disconnect the Arduino from the computer, okay, it's going and it's doing its dedicated thing, right? What if you design a project where you want to collect data? Let's say your Arduino, you're going to plug a temperature sensor board into the Arduino, and you're going to measure temperature and maybe humidity and some other weather type parameters. If you're getting all of those inputs, you're going to need to store them somewhere. The Arduino is going to run out of memory really, really, really fast. So you're going to need to store those somewhere. So you could hook it up to a computer and pull that data off the serial connection. So one of the things that they created was a library called PySerial. And of course, all of us, Python heads are going to sit there and go, "Yay, Python!" So of course, there's a library called PySerial, and project moved. Ooh. Okay, so here's PySerial, and there's its code up on GitHub. And basically, what this is a way to access an Arduino through a parallel port using Python. And of course, everybody knows that Python's pretty good at collecting data and storing it in places, so it's pretty good for data. So you can actually see right here, we've got some Python commands. Reading data from the Arduino is straightforward. Oops, I think I lost it when I went too big there. There we go. So you can see right there, import serial and serial.serial. Set up your connection. And while it's true, just keep reading the information from the Arduino. So right here is an example of using a Python. Even more examples of somebody using Python. And as I was reading this description, I thought this is pretty cool. What this guy is doing here is he's using a ultrasonic sensor to measure the distance between the device and a wall, say, or a device and desk or something like that. As he measures those distances, he records them. So he's basically saying that he's creating a virtual world of whatever it is that his room is using Python and recording all these distances, and now has measurements of a virtual world or of something in a real world. So you can see kind of like how maybe something like that floor sweeping device, that Roomba, might work, where you've got these proximity sensors or ultrasonic type things that measures, oh, there's a wall nearby, okay, and as it starts to record this data, it says, oh, I know there's a wall over there, I'm not going to go that far anymore, or something like that. So this is kind of a neat little project here. I myself haven't actually tried to do Python interfacing to the serial port at all just yet, but I think after reading this tutorial here, I might try it someday.
I believe there's actually a tutorial on the Arduino side on how to do some basic serial port stuff. It reads like probably like a variable resistor or something like that, and you can read it and watch the numbers stream across the screen.
Oh, cool. Yeah.
Yeah, there's a library and a little tutorial thing with this schematic and everything somewhere.
That's really cool. That's really, really cool. I'm just jotting that down. That's an idea. Cool. Does anybody have any questions? Anything else they want to see? Anything they, if anybody wants to try and poke at the code at all while we're here, or
if someone's interested in picking up an Arduino, do you have any suggestions as to where to find it, or is it just kind of find it where you can?
You can actually get them. They do sell them if they're still around. I understand that they're kind of changing. The ones that are left are going to be changing phase as to what they are. I guess Radio Shacks. You can buy them at Radio Shack. I know they've had them at Radio Shack. Like I said, I understand that most of the Radio Shacks are going to close, and the ones that are still going to be around are going to be selling different things. They might still sell Arduinos, but of course you can definitely get these online anywhere. You can get them through eBay, Amazon. In fact, the one website that I actually bought my Arduino from was a company called SparkFun, and you can find all different kinds of LED array. You can find all kinds of kits, Arduino, and they have. Okay, so just from this website alone, you can see right here that here's an Arduino Uno. This is the newer version of the board that I have. They also have an Arduino Pro Mini. You can see that's a lot smaller. So right here from SparkFun, you can get an Arduino Uno for $24, $25.
Okay. So what's the difference? I mean, obviously it's smaller, but the Mini, it doesn't have as much hardware on the board, right?
Exactly. Yes, you'll definitely have fewer pins, so you'll have fewer pins to it. Um, it might also be as far as current handling capabilities, to the pins, it might be a bit less. You probably wouldn't want to use one of these minis to drive, big actuators and switches in something a bit more industrial because it probably couldn't handle the current. But the Arduino Uno or something a little bit, bigger would probably be able to handle those amounts of current and that type of thing. So.
Okay.
So yes, and actually you can see that there's, even at this size, it's not really easy to see what size this is compared, but there are actually people that take these minis and I think they even have an Arduino Micro, I think they call them. Let's see. Let's go back to the Arduino for that one. Products, Arduino. Okay, so they have all different kinds of products here. They have an Arduino Pro, Mini, Micro. Let's take a peek at the Micro. There's a peek at the Micro right there.
What?
And I hear that people actually take these micros and sew them into clothing.
And what would you be able to do with that?
And one of the things, let's see, where is it? What is it?
Jamal, I saw someone who attached LEDs to the back of their coat for when they were biking in the dark, and had it powered by that. Yeah, right there, first picture.
Yes, here it is here. This woman here took an Arduino, and I forget which one this is called. I think this is one that's more flexible, that you can actually sew it into clothing, and it won't break. It's more flexible, that type of thing. You can wash it, I even think. And so, from what I understand, when I read this article a couple of years ago, she actually hooked inputs to her sleeves, switches on her sleeves, that when she wants to turn right or left, she basically just kind of pressure pushes the switches on her sleeves, and it turns on the turn signal, one way or the other.
Okay, that sounds like a fun project. Even if it's not turn signal, just being able to make Jack light up by pressing some buttons, or whatever it is, it's wearable.
Exactly. Anything wearable, you could you could just I can't even imagine some of the things people could probably come up with, and I'm willing to bet that if you probably let some young folks in front of these things, you can imagine the things they would come up with, because they usually come up with things that us older folks tend to forget about and not tinker with and that kind of thing. So
I think Arduino tie might be a fun project.
And you know what you could do with this? I'm just kind of picturing. You could kind of put several LEDs in there and make it be a binary counter in your tie,
like
that would show the time on your tie. But in binary, because of course if you're going to put the time on your tie, you're going to probably want to do it in binary, just so you can add that extra level of geek to it.
I might have to do that.
Cool. That is pretty slick. So, okay, so I think I'm going to flip back to the thing here and kind of leave Jamal's party lights up there. And that's I mean, I could probably go on for a couple more hours and everything, and I'm sure probably everybody's getting a bit sleepy and tired and stuff, but Arduinos are fun. They're definitely something, and Arduino is not the only one. If you go to that website, even that SparkFun website, you'll find other microcontroller boards instead of just the Arduino. In fact, you could even step it up and go, another level or two higher, and start with something like a Raspberry Pi, where you can actually start, writing something much bigger for it and that type of thing. So once you start tinkering around with an Arduino, somebody might, want to go to Raspberry Pi after that. So you can kind of get the idea that hardware and software, as much as some people like to think they're separate, they're really not separate anymore. They probably never have been. And for many years, they kind of seemed separate because, we really never, we don't really program our VCRs. We don't really program, listen to me, VCR. We don't really have any inputs to these things or access to these things. But if you think of all the stuff that they're doing with this Internet of Things, self-aware refrigerators that know when your milk needs, when you need new milk or whatever, all those types of things. We're not really going to be able to get away from software and hardware. So, as software developers, we probably want to be able to have some knowledge of hardware, and hardware folks probably want to have some knowledge of software. And I think the Arduino is a good project to kind of, bridge that gap, if there was a gap.
Yeah, definitely. That was awesome. Thank you, Craig.
Oh, hey, no problem. And the fact that you can, at least use Python on it, that's even cool as well. Yeah, because it is Python Thursday, right?
It is Python Thursday, for sure.
Now, just let me see if there was anybody in the group chat that put anything in there that we need to actually. It looks like Tiffany's gone for the evening there. So.
Yeah, she had to drop off.
Okay. Okay. So that was all I had, unless anybody else has any questions or anybody else had any ideas of something else to talk about with the Arduinos or anything.
I think that covered it. That was really cool. I enjoyed that. I want to play with an Arduino now.
And of course, if anybody hasn't heard of it yet, the Code Newbies is doing the Marches for Makers. Saran and Scott Hanselman are actually doing some things together. If anybody has not seen those yet, you definitely want to catch those recordings as well. There's some cool stuff in there. And I think they even, what was it, last week they unboxed a Raspberry Pi and got an LED to flash. So
that was a really cool event. I enjoyed that one.
Yes, definitely. And I even looked and saw that they have some more that kind of went back a few weeks that I wasn't even sure that I had heard of. I probably wasn't paying close enough attention, but there are others in the series as well.
Oh, cool. I'll have to post up the link for that one too. There it is.
So is anybody completely mesmerized by Jamal's party lights?
It almost reminds me of like a really small rectangular Christmas tree.
Like, what would you do if you pulled up to an intersection and you saw this pattern?
Drive very carefully.
Yield to crossing traffic.
Yeah, for sure.
Yeah, I took the demo code and I put 2 more global variables in it because the demo mode was too slow. So I put a scaling variable in there for that, and then I got a little, the actual light code was moving a little slow too. So I put a scaling variable in for that so I could run it faster.
Nice. Did you have the code available? Did you want to show it or?
Well, I just forked his code and added a couple of things, and basically where he has the time delays, I multiplied them times my scaling variable, so I can speed it up and slow it down. And
Okay.
so, if you look at my little webcam here, it's like running a twice as fast version of the light code right now.
All right, let me see if I can switch over here real quick. Stop. And oh wow, you totally set it up too. Look at that.
That's pretty cool. Sweet.
And so you can see it's moving a lot faster. And I can slow it down and make it go twice as long, so I can implement the 20-second delay that he wanted just by changing one variable.
Oh, cool. And that's in your repo up there?
Yeah, I can submit a pull request if you want. So.
That'd be cool. That'd be cool.
Nice. And are you using the same Arduino board that he's using, or did you have a different variant?
Mine is different in that you can see this processor here is the actual DIP package, but I believe it's the same processor. It's a, let me see if I can tilt this a little bit. So it's an Uno. I think it's an older version of the Uno. I may have actually got this. I actually got this at Adafruit. So I was posting some Adafruit links. They're really cool kit kind of manufacturer distributor. And they do a lot of things with Raspberry Pis and Arduinos. So this was it's the same thing as a SparkFun board type board where it has the breadboard and the Arduino came with it. And so I bought that, and it just has a different package, and I don't even think it costs any difference. I think it's just an older one. So, but yeah, it's I've got smaller LEDs on here too because I didn't have any large amber ones, so I only had the smaller amber ones, so I put those on there.
Nice.
So, but yeah, if you hold on here real quick, and I'll change this so that, let's see, make this like really fast.
And Larry, are you running that from a PC or a Mac Linux?
I'm running that from a Mac. I used to have all Linux computers, now I have all Macs. But I've actually used, this is, the Arduino software is built on something called AVRDude. And you can actually run AVRDude from the command line and upload to your Arduino. So you can create a sketch and, edit it in Vim or whatever, and then use AVRDude to push it to your Arduino. So
that's cool. That's cool. So once it's compiled, you can actually just manually do the push yourself.
Yep.
Oh, sweet.
So let's run a little bit faster, I think. Oh, no, there's an error. Hold on. What happened here? Done compiling. There we go. Now it's really booking.
I want to hit that intersection.
Yeah. Hurry, go. So,
Nope.
Or you can
Ticket.
Or I was just going to say, I wonder if that fulfills the mythical quota right there. You gotta get so many tickets. Speed the lights up.
I also hot wired my switch because I had a slider switch I was going to put in there. So right here, I've hot wired instead of having a switch here. I was going to put a switch in, but my slider switch kept popping out of my breadboard, so I just gave up. So now I've actually switched it back to the original speed. So the scaling's set to 1 now. So it's running at the speed that Craig actually specified in the code.
So is hot wiring that switch basically the equivalent of just having a car sitting on the side street?
Yeah, it just keeps cycling through the sequence of lights.
Okay.
It just never stops, It's and I actually my grand plan for this week, which I did not pull off, is to get some magnet wire and actually create a little thing and get some Hot Wheels, and you can run the Hot Wheel over it, and it works as like a pickup, like on a guitar, and you can run that into like a transistor and amplify it, and then send that signal to the Arduino, and that'll actually trigger the light. But I didn't pull that off this week. I got a little busy, but I was talking earlier. I want to go try to maybe get my Raspberry Pi out this week and do the same project, only using Python code with a Raspberry Pi. So I thought that would be kind of cool. Yeah. Hopefully I'll get that done this week, and if I do, we can run through that next week, and I'll post the code up on GitHub and post the link in the Slack channel.
Nice. Yeah, if you get that ready, let me know, or when you get it ready, let me know.
Yep.
Fun.
So, yep, and the other thing I did here, let's see. So I got the demo mode scaled too, so we can go party light mode on the demo if we want to. So, let's see. Go. Boom. It's so easy just to change it, and that, real quick upload it. You see all the lights flash, and boom, something changes. So There's some real great kits out there too. If you go to was it SparkFun, Adafruit, places like that, I bought one time. It has like it teaches you how to move a servo and about serial communications and a bit. What was it? There's a chip where you can. I can't remember. It's a bunch of stuff. It normally comes with like a 555 timer chip, which is a chip you can actually set up to emit pulses, and then you could have that be like a clock for your Arduino, even though there's one built into it, but you could do that sort of thing to trigger things. So.
Nice.
Yep. And if we want to, we could say, this party's a little bit too rambunctious here. We can slow this sucker down with about keystrokes.
I just got really mellow.
Yeah. This is like 3:30 in the morning. I've had enough. So yeah, that's my Arduino there.
Nice.
If you want, I can pull out my. I've got, I think, my other boards here. If you want to see some other boards that I have, got Beagle Bones, and this thing here is actually pretty interesting. This is a. Craig may recognize this. This is a PIC version of the same sort of thing. It's an ancient PIC version, and it's made by Microchip. And they kind of, in the history of this sort of thing, these things used to be pretty expensive. You're looking at $200 and up for programmers and things like that, and you had a lot of proprietary software involved. And when the Arduino came around, it like changed the game on this. And then you had people like Microchip, all of a sudden, who are like industry leaders, trying to catch up. And so they put out this little board here. I think this thing was like $9 or $15 or something like that. But you still had to plug into this thing here with a USB interface, and the software was real clunky. And eventually they came around. I believe they make a version now that's compatible with the Arduino software. So, and it's just a different type of microprocessor. It's programmed. This one is programmed in C or assembly.
Okay.
And you have your headers here where you can plug into things, and obviously you can solder in to these things here. So, and this actually, one of the things that's probably loaded on this thing right now is a demo that just flashes these LEDs that are built into it. So that's that type of board. This one's probably my favorite, and this is the Beagle Bone Black. And so it's on the same sort of, type thing here where you got a breadboard, you got headers here that you can use. It's got Ethernet port, there's power here. This is also power, I believe. And you have a USB port, or maybe that's the power there. And then right there, my finger is right over it. You can't really see it. Let's see if I turn this way. There's the micro SD that runs this entire thing, and that's running a version of Linux. So. And this one's pretty cool because when you plug it in, it brings up a web page that you can just instantly start reading and learning about how to use it, and shows you how to do some basic stuff in JavaScript. Now I have no idea where my yeah, I'm missing one here. My Raspberry Pi is gone. I'll have to find it for next week. So,
nice.
As you can tell, I kind of love these little things. They're kind of fun to play with, and there's a lot of cool projects you can do. That the BeagleBone Black, you can run Flask on that, and they have a tutorial on how to wire up a temperature sensor. And use Flask to serve a web page that you can monitor the temperature of your house.
That's pretty cool. You get that kind of interactivity from a nice GUI interface.
Yep. I mean, you can write yourself, obviously using a Flask template, you could write a little interface that, you could even send, obviously, post messages back to that. It's running a server. Send a post message back and have it do actions. You could actually hit a button on your web browser remotely and have trigger some pin on that board to do something. So, like put your garage door up or something like that.
Awesome.
Yep.
Yeah, thanks for sharing those.
No problem. I'll try to get the Raspberry Pi going next week, and we'll hopefully do a similar thing, only we'll be looking at some Python code.
That'd be really cool.
Okay.
Hey, Larry, what was the name of that third board that you mentioned?
This one here?
I think so, yes.
This is the one that runs Linux, the BeagleBone. It's called the BeagleBone Black, and I don't think they've updated it in a while. Oh, sorry. Turn my camera off. I looked, and I don't think they've updated this in a while, but it's still a pretty good board. See, it's got a Texas Instruments chip on a processor. It was actually developed by a guy out of the Texas Instruments Chicago office. I met him at a Linux festival here in Indianapolis one time. And so they were kind of inspired by the Arduino kind of movement and said, okay, they make this Raspberry Pi thing, we could do something similar. Their boards are considerably more expensive, but I think at the time, this came out about the time of the Raspberry Pi 1, and it was running a lot faster processor and stuff. So Raspberry Pi is probably the best value around if you want to run a small Linux computer. So.
Nice. Well, I got some stuff to order.
Yeah. Yeah. You can always hit up Amazon too. It's a good place to get stuff.
Oh, yeah, definitely.
Yeah. I found out I need to get more LEDs because I didn't have any of the large amber ones. I'm like, I'm going to go probably order, like 100 off of Amazon for, $10 or something.
That's a lot of projects.
I've actually heard a number of folks actually say to me at times, "Oh, well, your hobby's programming. That's kind of a cheap hobby, right?" And I'm like, "Well, sort of until I start getting into this kind of stuff."
Yeah. You can go once you get in like the boards and stuff. I've got some of the boards here, and I forgot this one. Like the shields you were talking about. You get in the shields, and all of a sudden it's like, well, I need a low energy Bluetooth shield, and I need and that gets into it. This is actually another Texas Instruments board. This cost me $4.30, and this is programmable as C, and this let's say, yeah, it's just a Texas Instrument board. It's a little demo board for their MPS 430 microprocessor. I think this is an 8-bit or 16-bit. I can't remember. It's called the Launchpad, actually. It's a little rocket down here. So that's pretty cool. I bought this thing for $4.30, and I plugged it in a couple of times and went, well, because at the time, I've had this for maybe 2 or 3 years. It was, fire up, what's that kind of real heavy IDE that runs on Java?
Oh, NetBeans.
Yeah, something like that. It's not NetBean. It's
IntelliJ?
No. Something along that. Eclipse, yeah.
Oh, yeah.
It's one of those three.
Yeah, it's one of those three. Load up Eclipse, download this plugin, blah, 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 blah. Took me forever to get the thing running, and I was like, yeah, I think I'll just go back to my Arduino.
Awesome. Well, that was really, really cool. I like that. I would love to see some more little board projects, I guess. I don't know. What do you call that? Hardware projects?
Yeah, I don't know, Craig.
I've
Maker
heard
projects, or
Maker projects?
Called collectively maker stuff.
Yeah.
I think that's a good term. I'm going to go with that one, maker stuff.
Because it just kind of involves a whole lot of things. I mean, even one of the libraries near me has a maker room, and they have a whole bunch of equipment in it. And I mean, that's kind of odd for a library. I mean, it's good, but it's actually odd. But not only do they have, the typical stuff you might think of seeing in a maker space, like a 3D printer and some Arduinos and some computers and stuff, but they have like sewing machines, they have embroidery kits, wood burning kits. I mean, you name it, just anything you can do to make something.
I signed up. There's a here in San Antonio. There's a mini maker fair at the end of the month, and I signed up for that. So I'm excited to go see what's going to be there.
Maybe now we have disco lights going now.
Yep. You delete a 0, and then it gets crazy. It's just fun, You could create the Cylon effect. You could actually run those all in sequence and make them red and make them go back and forth. And
ooh, you could turn your car to Knight Rider.
You could turn your car into a Knight Rider, and then you could go one step farther and put in a variable resistor that you can change the speed on the dash and things like that. You could. I mean, think about it. The Google car thing uses something very similar to that ultrasonic ping thing Craig was talking about. I actually wrote a program to do that when I was in college using an Atari 800. That was horrible. So we used it for a physics class, and then we bounced racquetballs underneath of it and measured the distance and speed. So, but that sort of ultrasonic thing is the basis of like radar or your backup sensors on your cars and things like that. And if you think about it, you can build them very cheaply, mock them up with this kind of hardware. So. My brother actually asked me. He has a full-size stoplight. I'm not exactly sure where he got it from. There's probably an intersection missing one around here somewhere. And I went over to his house one day, and he was like, "Can you wire this up to turn red when I pull up so close to the front of the garage?" Kind of like those things you can buy where it tells you to stop. And I was like, "Yeah." And I was going to use the Arduino to do it. And then I started talking to him about it, and I was like, "Yeah, we're going to have to buy some relays and stuff because that thing is running on at least 110 or something." We were starting to have to figure out how to interface an Arduino to real hardware, and he was like, "Nah, I'll just go buy one of those things from the hardware store."
Huh. Wow. So many things you can do with it.
Yeah, I mean, they really enable you to do a lot of really super cool stuff from moving up and down your garage door remotely. And I saw a tutorial the other day, and if you're interested in this stuff, there's I could probably find some links to some of the blogs that I kind of follow, but using lasers to transmit high definition sound across a room, and it all starts with small boards like this that guys just program and hook, interface those sort of things up to. So.
Huh. Right on. Well, thanks so much. Thanks, Craig. Thanks, Larry, for demoing your stuff tonight. And I've been really inspired. I'm excited to go grab some stuff and start playing with it and seeing what I can do with it. So.
Yeah, this has been really good.
Yeah, totally. And to anyone watching, thanks for watching. Thanks for tuning in. Hope to see you next week. Maybe we'll have some more. What would we call them? Maker things next week.
Yeah, Marches for Maker follow-up.
That's right.